How many terms make the sum of 60,466,175 for the series shown? The series is 5 plus 30 plus 180 plus 6 480, and it looks like we're multiplying by 6 each time, so the r equals 6. So let's use the sum formula for the geometric series. S sub n equals a sub 1 times 1 minus r to the n power divided by 1 minus r. So let's substitute what we know here. The sum is this big number, so that's going to be the S sub n. It's going to be 60,466,175 equals, now the a sub 1, the first term we know is 5, then it'll be times 1 minus r, the common ratio of 6, to the n. We don't know how many terms, so we're going to leave the n. That's the unknown. Divided by 1 minus 6, the common ratio again. Alrighty, so let's simplify this a little bit. 60,466,175 equals 5 times 1 minus 6 to the n divided by negative 5, because that's 1 minus 6. Now the 5 and the negative 5, those reduce out and leave a negative 1, so you're going to get 60,466,175 equals the negative of 1 minus 6 to the n. So we'll divide by a negative 1 and get negative 60,466,175 equals 1 minus 6 to the n. So we're going to try and get this 6 to the n by itself, and then we'll solve for the n. Subtract 1 from both sides. That's going to give negative 60,466,176 equals negative 6 to the n. And divide by negative 1, because we have a negative on both sides. 60,466,176 equals 6 to the n. So here's the question. How do we solve for this n that is in the exponent? You're going to have to think back. You're going to use a logarithm. So we're going to rewrite this in logarithmic form and write it up here. So it's going to be log base 6, because 6 is the base of the exponent, of 60,466,176 equals n. Remember, for a logarithm, the logarithm expression always equals the exponent, and the exponent is n in this case. So we're going to use a change of base formula. Log of 60,466,176 divided by log of 6 equals n. So let's get the calculator and see what we get. So log of 60466,176 close parentheses divided by log of 6 close parentheses, enter, 10. So 10 equals n, and that means it takes the sum of 10 terms to make that big sum of 60,466,175.